Welcome back to our grade 10 maths lessons. Miss Awinu Pia, I'm glad we could be together this term again. I hope you had a good break. This term, we are starting off with circle geometry, all right? Now, what is circle geometry? Before we get to that, don't mind the diagram on the left. We will come back to that at the end of the lesson when we are applying our properties, okay? So, what do we mean when we talk about circle geometry? Simply lines that are drawn in a circle and the angles formed by those lines, okay? So, let's start off with, we won't draw this circle too big, and please don't mind how ugly the circle may look, so long as our lines are shown on the circle, all right? We make sure the center of the circle is marked, and we always mark the center with an O, okay? Now, you've learned about circumference in lower primary school, and you've continued into high school with it. The circumference is the term we use for perimeter when we are looking at a circle, all right? Perimeter, you know, is the measurement around an object, any object for that matter, but when we look at circles, it's referred to as the circumference, okay? Like I said, you are already familiar with this term. Now, circumference, then we have the lines drawn from the center of the circle, all right? This one is referred to as the radius, okay? Then we have a line that runs from one end of the circle, or this circumference, through the center of the circle to the other end here, or the other circumference on this side, is referred to as the diameter, okay? Diameter. Let's draw a line here, an arrow, so we can identify that. That's your diameter, okay? Then there are other lines that we are going to learn about in this lesson. The first one being the chord, okay? Now the chord also runs from circumference to circumference, but it does not pass through the center, okay? That line is known as a chord, okay? Another line which we will be looking at is the line that is drawn outside the circle but only touches the circumference at a certain point, okay? This line is referred to as the tangent, okay? The tangent. And the last line is a chord, but this chord does not stop at the circumference. It is extended outside, all right, and continues outside the circle. That line is referred to as the secant, okay? Now, those are the lines that we are going to be using to form angles, and we are going to see how those properties are going to help us find the size of different angles, okay? So there are 4 chord properties, all right? We are going to use diagrams to help us go through those 4 chord properties, okay? The first one, and we're going to use diagrams, all right? So here's our circle. We have the center of the circle marked by O, okay? If I draw the diameter here and use that diameter to form a triangle, okay, can you see that? That angle at the circumference, this one here, is 90 degrees. So let's say this triangle is ABC, and include this angle, we say D. All right, so angle ABC is 90 degrees, which means that triangle ABC is right angled. Okay, so angle ABC is 90 degrees, which makes triangle ABC a right-angled triangle. Now that is also true for the triangle that is formed on the other half of the circle. Okay, so this is property number 1, where the diameter is used to form a triangle. Okay, that triangle will always be right-angled. Now, our second property, all right, again we are using chords, all right. So if I draw a chord here, all right, and I form 2 angles at the circumference of the circle, like this, all right. We have this chord sitting on this arc, and these 2 angles are sitting on this chord and arc, all right. What's so special about the angles? Okay, because they are sitting on this chord and arc, they are equal, all right. So angle DAC is equal to angle DBC, this angle and this angle, all right. Once again, if 2 angles are sitting on the same chord or arc, they are equal, all right. So they are equal angles. Now, property number 3. They're not very difficult to remember, so long as you remember how the diagram looks. Okay. Property number 3, again, we need to mark the center of the circle. All right. Here's our chord. We're going to draw this. All right. An angle at the circumference and an angle at the center. Okay. Now, again, the angle here and this angle here are sitting on the same chord and the same arc, all right? But the property here states that this angle at the circumference is half the angle at the center, okay? So let's say A, B, C, and the center is O, all right? Again, that property, the angle at the circumference is half the angle at the center. So let's write that out so we don't forget. Angle CAB is equal to half of angle COB. All right? That's property number 3. This angle is half of this angle, or we can say this angle is 2 times the angle at the circumference. All right? Now, property number 4. We're almost done. Now, this one is probably the easiest one to remember. If I have a quadrilateral drawn inside of a circle, okay, those quadrilaterals are referred to as cyclic quadrilaterals. All right, a quadrilateral drawn inside of a circle. Okay, so let's say this quadrilateral is ABCD. Okay, now property number 4 states that opposite angles are supplementary. What does supplementary mean? We should know this adds up to 180 degrees. Okay, so in this diagram, angle A is, or if we add angle A and angle C, that will give us 180 degrees. Okay, and angle D plus angle B is also equal to 180 degrees. So opposite angles are supplementary. Right. Now, those are the 4 properties in relation to the line here, the chord. Okay. Now, how do we apply these properties here to find the size of a missing angle? Now, this is where our diagram comes in now. Okay. So, if you look at our diagram, we have here the size of angle B is unknown. Okay. And we only have this information given. Angle here is 48 degrees. Now, how am I going to find the value of angle B? We need to look at our diagram carefully. The line AC here is the diameter. You can tell because it runs through the center of the circle here. So if this is a diameter, the triangle on this side is a right angle. And this side here is also 90 degrees. Okay, which means the 2 triangles that are formed here are 90 degrees. How do I find B? I will need to find the value of this angle here. Okay, that is easily found because we know that 2 angles are complementary. Complementary meaning they add up to 90 degrees. So, using that rule, you simply subtract 48 from 90 degrees, which will give you 42 degrees. Okay, so this angle here is equal to 42 degrees. All right, so what is important? You can tell that they are sitting on that chord BD, which means that angle 42 and angle B here are both equal. All right. Now, just imagine if the line AD was not there. Then you would recognize that the diagram looks like this. Okay. The diagram looks like this. So the chord is here, the arc is here, which means that the 2 angles formed at the circumference are equal. All right. So angle B, all right, is equal to 42 degrees. Okay. Now, as we go a little bit more into circle geometry, you will see where we apply the other properties. Okay, that brings us to the end of the lesson. I hope you have learned something. In our next lesson, we are going to look at the tangent properties. Okay, the tangent is this line here. So we are going to look at the properties associated with the tangent. Thank you for being with me. I'll see you in the next lesson.